In this video, we'll look at exponents and square roots. So let's start with exponents. A power is a number that can be expressed using a base and an exponent. So this whole thing, 5 to the third, that's a power. My base is 5, and the exponent is 3. Now, an exponent tells you how many times you multiply the base. So let's take a look at expanded form for 5 to the third. Expanded form for 5 to the third would look like this. We take our base and we multiply it 3 times. So there should be 3 5s. So 5 times 5 times 5. And that is expanded form. And then we have what's called standard form. Standard is the way we're used to seeing the numbers. So what is 5 times 5 times 5? Well, 5 times 5 is 25. And then 25 times another 5 is 125. So we have our number in exponential form, 5 to the third power. Expanded form means 5 times 5 times 5. And standard form is 125. All three values are the same. They're all equivalent. All right, let's practice with some of these exponents then. I have 2 to the fourth. That's exponential form. How do I write that in expanded form? Well, 2 is my base, so that's the number I'm going to use to multiply. 2 times 2 times 2 times 2. And now I've used that 2 1, 2, 3, 4 times, so that's 2 to the fourth. What does that equal to? 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So 16 is what this is in standard form. 8 to the third, that means I have to use 8 as a factor 3 times. 8 times 8 times 8. Well, what is 8 to the third? What is 8 times 8 times 8? 8 times 8 is 64, and then I got to figure out what is 64 times 8. I don't know it off the top of my head, so I'm going to do some work along the side to figure out that 64 times 8 is 512. And then finally, I've got a number in expanded form, and I want to write it in exponential form. So 10 times 10 times 10 times 10, what is that going to be in exponential form? Well, how many 10s am I using? I'm using 1, 2, 3, 4. 10, the number I'm using as a factor, is my base. And however many times I use it, 4 is my exponent. 10 to the fourth is 10 times 10, which is 100. 100 times 10 is 1,000. 1,000 times 10, 10,000. All right, well, what about a problem like this? 3 raised to some power is 81, and I want to know, what is that exponent? Well, let's fill out what we know. Standard form, that's 81. Exponential form, I don't know. 3 to some power. I don't know what that exponent is yet. Expanded form, I have to use 3 as my factor. So 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. I use the 3 4 times. So that x is a 4. All right, for the second example, 2 to some power is equal to 8. Again, 8, that's my answer in standard form. I want to figure out how many times do I have to use 2 as a factor. Well, 2 times 2 is 4. I'm not there yet. But if I multiply by another 2, then I get to 8. 2 times 2 times 2 is 8. So that means 2 to the third power. That x is equal to 3. All right, now let's find out about square roots. So the symbol for a square root is called the radical. That's what this symbol is here. And when I find a square root, I'm really asking myself, what number multiplied by itself results in this number under the radical? What number can I multiply by itself will give me 16? Well, that would be 4, because 4 times 4 is 16. Notice you can't do something like 2 and 8, right? You're trying to find the one number multiplied by itself that gives you 16. These numbers are special. They're called perfect squares. So a perfect square is a number that has an integer as its square root. So let's look at the square root of 16. Do you notice that I can count up all of these dots and there are 16 of them, right? And that square that it makes is a 4 by 4 square. So for the square root of 16, you can see why that is equal to 4. But what about the square root of 36? What number times itself is 36? Well, hopefully you're thinking of your times tables and you say, oh yeah, 6 times 6. That's 36. But notice what's happening here with the squares. There are actually 36 of these little dots. And if you notice, we can make a square with those 36 dots, and this square is a 6 by 6 square. That's what it means for these numbers to be a perfect square. Now, what would the square root of 81 be? If you said the square root of 81 is 9, you would be correct. All right, last two here. Let's talk about perfect squares. I've got 10 dots here. Is there a way to make a square with 10 dots? Like I had that rectangle there, but not a square. There's really no way to make a perfect square with 10 dots. So the square root of 10, the answer for that is not an integer, right? There is a number that's equal to the square root of 10, but it's not a whole number. But what about the square root of 9? If I drag these dots around, you can see I can make this into a perfect square. And what's the size of this square? It's a 3 by 3 square. So the square root of 9, what number times itself is 9? That would be 3. And that's how we work with exponents and square roots.